All right. All right, Brad, are you going to be my clicker? Oh, yeah. Okay, take two. Sorry about that, guys. First of all, thank you everybody for showing up. This is an awesome turnout. This is our third talk in our Saturday workshop series. This talk is called Botnets for Beginners. A couple slides, I'll kind of go into details about exactly what this is going to cover. And go ahead, Britt. Got to get the legal crap out of the way. This is for educational purposes only. So if you choose to use this in an improper fashion, you'll probably go to jail. Say hi to Bubba. Also, just as with most stuff at the range, there's going to be some offensive material that will bother you in any way, shape, or form. Now's your chance to leave or forever hold your peace. So, all right, go for it. Okay, a little background for me. Been volunteering at the range for over 2 years now. I've been doing 1.5 years incident response at a major university. Got a bachelor's degree, associate's degree in computer programming, and if you ask the FBI, I am the local recruiter for the Taliban. Just one thing of note, especially for the newer volunteers here, like pretty much everything I'm showing you today has been learned here. Like even with my programming background, my computer degree that I got, that taught me the fundamentals, kind of like the foundation that you need to know as far as programming goes, but the actual implementation and the methodology was all learned here. So just keep that in mind. Yet another reason to go to the range to learn, because you actually learn by doing here. So what this talk is about, basically we're going to outline the basic concepts necessary to implement a distributed computing system, which is a fancy name for a botnet. We're going to cover the design, the technologies you can use, and how to implement them. We're going to do high-level examples of good guy and bad guy implementations, and we're actually also going to hopefully kick off a live demo of one of the good guy implementations. The other thing that I want to kind of emphasize in this talk is it's really not that hard. You hear about these, massive botnets doing all these crazy things, or even the word distributed computing systems can even be intimidating. And yeah, the idea that I'm trying to convey with this talk is that really anybody can know it. If you know just a decent amount of programming, you can accomplish this. And finally, this is not the be-all, end-all way to do this. However, this is a very effective system. I've used it many times. Brett's used it a lot, and it works really well. All right, wait, go back one. Just backspace. Nope. Okay, so basic concepts. Any botnet that you're going to have is going to consist of these three parts. Probably everybody here has heard of command and control. It's basically a web server that is going to host scripts that will act as an intermediary between the bots that are doing the work and the database on the back end. All these botnets and designs I'm going to show you are data-driven. And so having an effective exchange layer between the database and the bots is very important. The database itself, a huge component of making these work is in the design of your database, and we'll dive into that in a little bit. Let me back up really quick. For the command and control, the scripting language we're going to use for that in all of these examples is PHP. MySQL is what we use here at the range for our database backend. It's just highly compatible, it's free, easy to use. And then for the bots, that's the third component. Those are basically your workers. They are going to perform the actual task that you want your botnet to do. Python is what we're going to be using for these. The amazing language, easy to learn, and easy to work with the other two languages. All right, go for it. This is a this is a super high level layout. You know, it looks simple, and that's because it is simple. You have your database, the web server in between the bots, and you'll notice the very last one is numbered N. That's basically just representing that you can have literally as many as you have the server space for. You can, all of the bots are essentially going to be on virtual machines. You can have multiple bots on the same server. They can be geographically distributed across the globe. Essentially, the more bots that you assign to a given task, the faster that task will be completed. Go for it. Okay, so a little more detail on the bots themselves. Like I just mentioned, you can have from 1 to n number of bots on your grid, and you can scale that as high as you want. They can either all do the exact same tasks. For example, if you had a botnet that was doing a DDoS, or they can be automated to perform in sequence, which we'll actually show you in a minute with the demo. We're going to try to demonstrate the first chunk of our small business vulnerability scanner. The other great thing about this bot design is they can be run on very lightweight virtual machines. You can literally get away with the 256 mega RAM Ubuntu server on a VM to accomplish most of your goals. So you got to figure even on a single server, you can, you're basically limited to how many cores of processor you have. And as I mentioned before, that you can host all your bots on one server, or they can be geographically separated. You can literally have them all over the globe. That's the beauty of having the web interface as your intermediary, because you can just point the bots to either the domain or the IP that's sitting on, and they can get their instructions that way. And a well-designed botnet can allow for the scaling of bots in real time. So you can have, you can set it off, and if a specific task is not performing as fast as you want it to, you can literally just make another clone or multiple clones of that same bot, turn them on, and then based on this design, they'll just pick right up where the other one's left off, and you can just keep adding it until it goes to the speed that you want. And then, yeah, essentially the workflow is it's going to basically sit there and ping your web server and say, hey, give me work, and then when the queue table, which we'll get into in a minute, is finally populated with a work task, the server will then send the data that the bot needs to perform whatever job that it's doing. And then once that bot has processed the task, it will then send data back to the server to update the database and potentially trigger other bots to do other jobs. All right, a little more detail on the web server. So as I also mentioned before, your web server is going to act as the intermediary between the bots and the database. Essentially, the bots are going to be pinging, in this case, the PHP scripts saying, hey, give me work. The web server PHP script is going to query a queue table looking for work. If it finds work, it will output that to the bot, and then it will immediately update the queue table, effectively deleting it from the list so that when the next bot queries, it will get the next order task. As far as size on this, you can generally get away with just a 1 to 2 gigabyte RAM Ubuntu Apache server. Nginx works really well too. And just a pro tip, especially with Ubuntu 16, they changed a lot of the PHP libraries, so make sure that your code matches with the libraries it's using, because that bit me in the ass pretty hard not too long ago. All right, go for it. All right, so the database. Proper database design is crucial. Just when you're doing databases in general, even if it's not on a botnet, you want to have well-structured tables. But kind of the magic of a botnet database is the existence of the queue tables. So you're going to have your tables that are long-term storage that you're going to dump the results from all of your jobs so that you can run a reporting tool or anything you want on it. Simultaneously, you are going to upload queue tables, which are effectively going to act as a trigger for whatever bot you're queuing for. So in the demo we're going to show in a minute, The user will go to a web form. They're going to enter in a domain. That domain is going to be uploaded to two tables. One will be called the domains table that's going to assign a case number and a domain ID to that. And then it's also going to enter into a queue table where we have a subdomain brute forcer that is checking for that. When it finds a domain, it'll do its work. It's going to then post its results to a long-term relational table where you'll have a map from the root domain to the subdomain, and then you also have a queue table where an IP lookup will be done on that subdomain. It'll make more sense when I show it in a minute. Sorry about that. The other really neat trick is to have what's called a logical delete column in all of your tables. Instead of when you're done with your data, just deleting it and not being able to recover it, you have a column called logical delete, which is just a single bit that you flip either from a 0 to a 1. And then you structure your search queries based on whether you're looking for something that's not deleted or something that is deleted. So you would just say, select every record from this table where logical delete equals 0. That would show you everything you have that's not deleted. If you did the same query where logical delete equals 1, that could actually show you stuff that is deleted, so that data won't show up in your search queries, but it's still there if you need to go back and find it. And then as far as sizing the VMs, that's purely going to depend on the amount of data you think you're going to be processing. Go for it. Okay. Short little interlude here. I told you it was going to be slightly offensive. Got a no good Arizona subwoofer range talk would happen without a terrorist joke of the day. So, Mr. Taliban is headed to the market with 100 of his goats. He's going to meet his friend, Mr. Al-Qaeda, who's bringing 150 goats. Here's a question of the day. How many strip clubs can they open with all their goats? The answer is 0. Neither of them want anyone to see otherwise naked. There you go. All right. Yeah. Fuck terrorists. That's all I got to say. All right. So, kind of went over this, but just kind of reiterating it again. So, like I said, user is going to supply your initial trigger. In the case of the demo, it's going to be a web form. And essentially, that's going to be entered into a queue, which will act as a trigger. The first bot is going to be polling the server for work. Once it gets that, it's going to perform its task, post the data back to the server, and then it's going to update the long-term storage and then the secondary queue, and on and on and on as long as you want it to go. Oh, man. All right, that looks crazy. Okay. So the next few slides are code snippets from the actual demo I'm going to show you. If at first it seems a little wonky, just kind of bear with me for the next few slides. I'm going to pause after this, and then if anybody has any questions, I'm totally happy to answer, but I'll see if I can get through this explaining. So this is from a Python bot whose job actually is to do IP address lookups based on a given domain. So the part I have underlined here is essentially doing a post request to the getDomains.php, and the parameter that it's passing kind of cut off there, but it just all it says is a equals I. Now it looks kind of wonky at first, but it'll kind of be better explained in a minute. The A can literally be named anything you want. That is the parameter that you are sending back to the server. The reason I use a single character is I'm effectively shrinking the bandwidth that I'm sending in my post. So if you do A equals I, the data portion of your packet is only 3 bytes. And then the I is basically, as you'll also see, effectively what will trigger a certain SQL query on the PHP side. So, and then just below it too, you see, if reply equals NA, that basically means that there was nothing in the queue table. It's going to wait 10 seconds, and then it's going to go back to the top of the loop, ping the server again for work. All right, go for it. Okay, so this is chunk number 1 of the PHP the get domains that it's posting to. And you can see here, I have an action variable that I'm assigning to that parameter A. So in this case, the action will equal I. And then I'm just instantiating other variables that I'm going to use later on in my query. Okay. Looks a little wonky, but I'm going to try to explain it as best I can. So the very next to the number 1, you see the action equals I. So that's getting the literal value of that A parameter that we assigned to action. And this is basically saying, okay, hey, the bot just pinged I, which for me referenced IP lookup. So because of that, I'm now going to perform all of this work. Next to number 2 is our first SQL query where we're selecting from the IP lookup queue where logical delete equals 0. So show me ones that haven't been deleted. Ordered by entry date, descending, basically, putting them in chronological order, and then limit 1. So only give me one subdomain to do the IP lookup on. And then this is saying in number 3, if you find a result, you're then going to assign different elements of that record that you got. So we have a domain ID, subdomain ID, and then the subdomain name. What is echoed here will be returned to the Python script as the data that it's then going to use to perform its work. After that, we need to update the queue table. So basically here I'm flipping that logical delete bit to a 1 instead of a 0. I'm basically saying effectively delete it from the queue table so that the next time you're pinged, you're not going to give the same work again. And then down here, the number 5, if it doesn't find anything in the queue, it's just going to echo NA, which will make the bot wait for 10 seconds. And then this is coming back to the Python bot, so I'm kind of just trying to go through the signal flow. That bot is going to take those 3 pieces of data. It had the domain ID, the subdomain ID, and the subdomain, perform its work, and then this part is basically showing the post to a separate script called update IP. So now I've performed my work. I need to record that into my database for storage, and then I also need to set up my new trigger. So, and real quick too, so you'll see I have different parameters here. I have one for DI, short for domain ID, SD for the subdomain ID, and then IP is the IP address that it found. And we'll see that in a second on the next slide. So this is going now to the update PHP page. See those exact same parameters, the DI, the SD, and the IP. I am now taking the actual data that's assigned to those parameters and assigning it to the corresponding PHP values. And then this looks a little wonky, but once again, it's really not as complicated as it looks. It's just broken up into 3 queries, and they're each doing a very specific thing. The first one is putting that data into long-term storage. In this case, it's a relational table that's mapping the IP address to the domain. And you can see here we're inserting those values, subdomain ID, domain ID, subdomain ID, and the IP address. The second middle block is updating what's called port scan queues. So now this is actually going to trigger an nmap scan on that IP address that it just found. And then the third block here is going to an IP owner queue. So it's another interesting way of doing this is you don't necessarily have to only trigger a single queue. Like you can have data from one bot actually trigger a multitude of other bots. It doesn't just have to be a one-to-one relationship. So in this case, as soon as data is updated here, it'll actually spawn 2 jobs simultaneously. One will be a port scan, one will be more information on the IP itself. Okay, and then this is just a kind of a diagram of that signal flow. So we have the web form trigger that's updating the 2 tables, long-term table and a queue table. You have the get work in the middle, which the bot is querying. The get work sends the data, bot 1 processes it, goes to the update. Update then does a long-term in the queue, which we just saw. And then bot 2 then pings that query, and then it just literally back and forth. Think of a ping pong effect. So, all right, next slide. Questions? I know that was a lot. If I went too fast, I can explain something again. We're right after this. We're actually we can show that exact thing I just explained actually in real time, and you can kind of get to see the signal flow too, if that'll help. Questions? Oh yeah. Yeah.
Have you thought about using a distributed hash table to minimize single point failure? I know it's a pain in the but
I have not.
You're talking web to web. So, for example, you might have a courier set that is bots that are sitting on your server side that are waiting to query the work that's coming in from other locations. So you can have bots that are moving the data to other places, and that is going to be a lot easier and semantically the same. In addition to that, the things that are doing the carrier version are also the noise that helps you obfuscate the data that's being transferred. All right, so there's a reason why we're logging into these machines over here. The stages that he outlined, there are stages that complete very quickly, and then there are stages that go slowly. So, for example, the IP owner lookup, the RIP to a domain name, all of that happens very, very quickly. However, Nmap scans happen very slowly. So in the scaling of this particular botnet, we have 4 bots. One is essentially the initial queue that triggers the other stuff. We have 2 other bots that are dedicated to the IP lookup and the ownership lookup, and then we have a total of 5, 1 local and 4 down the side here that are doing the Nmap scan for all of that. So the Nmap scan obviously takes the longest, so that's where we are distributing the largest amount of work.
Go for it. Hit escape. Okay, now we're gonna do a demo here. We're gonna should just be able to pull up the Google. And then I have it queued. And you just got to do in the domain name. So we're going to say hi to our friends. I don't know if you can even see it. Oh, it's actually cut off. That's funny. Doing NSA.gov just to say hi. So minimize it. Minimize that. Yeah. Yeah. Not quite.
Okay, so the top bottom on the left up there is doing the subdomain brute forcing.
Yeah, that one takes a few seconds, but once it kicks off, you'll see it doing the post. There it goes. So that each one of those is a post to the web server, and that's kicking off this guy here. And
so these are the owners of those IP addresses. All the subdomains it found. These are now the owners of those subdomains. This is an initial Nmap scan of the first target, and then, I don't know, that one's sleeping.
Yeah, demo guys are hating me. But you can see on the side here, it kicked off Nmap scans on all those too. So it's literally each one of these bots is grabbing the next IP to perform work, and they will just continue to grab it in sequence until the job is totally completed. So you can see how fast that went. Like that was the entire subdomain space of NSA.gov.
And it's not scrolling back quickly, but each one of those have also picked up part of the assignment. Oh. And so you can see this guy at the bottom right is doing his work on the Nmap scan, and these guys are also sequentially participating, also performing their own processing of that workload. And you can see that our scale's a little bit off because we got through that really quickly, and these are taking forever. So this is where we spend all of our time provisioning new bots to help us with the Nmap scan to speed it up so that it all happens very, very quickly.
Yep. Any questions? Yes, sir. We're basically covering the design and implementations of botnets and how to use them for production. In this case, this actual system, once we're finished, is going to be used to provide vulnerability assessments for small businesses through InfraGard. So this is a botnet for good, you could say. And then in a little bit we're going to get into how you can also use it to have fun. So yeah, we'll go back to the PowerPoint. Other questions? Yes, sir. When at the end of the demo, I can pull that up for you. Does it? Okay. Awesome. Okay, here we go. A very hypothetical example. Oh, yeah, next slide. So here's our scenario, hypothetical scenario. So we wish to inflict some digital pain on a region of the globe that has an affinity for goats. You have a juicy exploit that will allow you to compromise a large number of assets in that region. How do you automate this so that you can achieve maximum pwnage in the shortest amount of time? The answer is a botnet. So pregame, so just like any other hack, you got to do your recon. If you're targeting a vast region of Earth, you need to use a faster port scanner than Nmap, otherwise you'll probably die before it's done. The answer for this is a tool called MassScan. I don't know if any of you guys in here has used it. It is awesome. If you can change how fast you want it to go, and on its fastest setting, it can actually scan the entire internet in 3 minutes.
You mind mentioning that the recording is going to be online, because I see everybody with their phones up.
Oh yeah, so yeah, just an FYI, I guess we're recording this and it'll be posted online, so if any of you guys are interested in that. Also with MassScan, another tip is because it works so fast and it's sending out a ton of packets, you will actually DOS yourself if you don't throttle it back properly. I hypothetically found that about 1,000 requests a second is right around the sweet spot. So once you've done your scan, you want to parse out the scan results. In this particular instance, we just want to make a list of IPs that we want to go after, and then we just basically write a script that'll dump those IPs into a queue table, which will act as our trigger for our exploits. And now we are good to go. So as far as like the VMs and setting everything up, in this particular case, the data set's really small. It's just an IP list. So you can put your database and your web server on the same box, and it'll actually speed things up a little bit. Each bot will have literally it'll be a bare bones Ubuntu server running just a single Python script. That's all you need, and then you just replicate that as many times as you feel you need. And it can be anything, and just the more bots you have, the faster the work will be accomplished. And if you launch it and it's not running as fast as you want, you simply just add more bots. Okay, the execution. This kind of said before, each bot of the VM will be exactly the same. They will only be running the script you've written with the exploit. And then the way the scripts are going to work is they're just going to query the server for the target, perform the work, and then update the server saying either, hey, the exploit worked, or hey, it didn't, and then it'll just update a second table that'll just give you a list of boxes that you've compromised. So, and this should now look familiar. So this is essentially the layout of said hypothetical botnet, and just the box around the database and the server just representing that's on the same box. But like I said, really simple design, incredibly powerful, very scalable, very versatile. You can program these bots to do anything you want. You can write custom scripts. As you saw with the demo, the very first one was running a program called Sublister, which somebody else wrote. You can just basically put a wrapper around a already existing program or script and just feed it data as input and then parse whatever output it gives you. Nmap's another example, right? You're simply, in that case, taking in an IP, plugging that into your Nmap query, running Nmap, and then taking the text file output, parsing it, and then sending the data back. All right, there you go. And hopefully it all works out and you get the very nice, great success. And all right, more questions. Told you it was gonna have goats and all sorts of shit. Yeah. Oh yeah. Hey, everybody thinks I'm in the Taliban anyway. May as well roll with it. So, exactly. Yeah, just kidding, FBI. All right. Anybody? No questions? Go for it.
So if you were to deploy this hypothetically outside your network, if you don't mind it coming back to you, would you then create a script that would remove it after it's done?
You can.
And then this way, after each node within your plot is done doing it, removes evidence of itself so that it can't get traced back to you itself.
Absolutely. Yeah, you can program it to wipe itself. You can also automate the replication too, so you can actually have something that checks the length of your queue list, and if it gets beyond a certain threshold, you can then automatically spawn new bot instances. Yeah, you can do it in both directions, spinning up new ones and removing them. Yes, sir. Yeah, you can. They're completely interchangeable, just as long as they're pointed at the right IP address and the data that it's parsing back and forth is compatible. Yeah, you can do it in real time. Yes, sir.
So the purpose of this, as far as playing warfare range, is to help small businesses just their.
That specific demo, yes. The methodology we use in a ton of different things. We have a version of it is our management system. We have our forensics range basically works exactly this way. And that is actually one thing that I want to put out there for anybody that is a programmer or wants to be a programmer that is interested in this. Please come see me or Brett. We are looking to teach more people how to do this. We have a lot of projects in mind that we want to do. So yeah, we're definitely looking for help because there's so much to be done and not enough coders, and we are happy to teach you. And also after the presentation, if any of you guys have any other questions, please feel free to ask. And is there any other general questions?
For help from any of these two guys on the CCP stack.
Yeah, maybe not.
I mean, our network. Were there any ghosts harmed in making of this presentation?
There were not. Yeah, just pictures. Yeah. And
no, that's permanently.
No.
Just to be clear.
Okay. Going once, going twice. I believe that is it. Yeah. Thank you very much, guys. I went back quicker than I thought. Thank you. You want to talk about the next couple of talks? Yeah. David's going to give you guys some updates on what we have coming up for future talks. Oh yeah. All right.
All right, guys. So as you see, this is why I don't use microphones. I always talk too loud. So if you don't already know, we've been trying to do presentations here at the range every 2 weeks. In the next 2 weeks, we're gonna have a guy from a firewall company come do a demo on how they're accessing information from the iPhone, such as taking general contacts out, just general metadata that travels through phones just by plugging straight to it. So he'll be extracting, to what I remember, it was contact information, so phone numbers, names, emails, all that fun stuff. And then 2 weeks after that, we're gonna have a lady from ASU hopefully do a presentation on research in the dark web. There's different names that they're using, but I think they said dark web is what they're doing research in. Question? Yes. So it is. If you went to last week's ISSA conference, it is the same lady that did the presentation there. Although since this is a cyber warfare range, it's not going to be dealing with any like, oh, I'm a political person, I'm not going to be, because no, fuck you guys. This is an open, free range. You can do as much shit as you want. So it's a completely different atmosphere. Did you raise your hand again? No. Okay, sorry. So that's what we have coming up. I think somebody else around here has another presentation going on. Yeah, Brett had more info on that one. Did he take off? Yeah, you said that there was another presentation that we may be doing. The two guys did.
Oh yeah, take one.
Yeah, what were they working on? Yeah, I have memory loss, so I can't remember. Say again? A game.
Oh yeah, X game.
Oh yeah, so red team, blue team, right? Or actually no, that's separate. But yes, look forward to red team, blue team competitions at a much larger scale coming pretty soon as well. What else is there? Oh yeah, so they're doing some games there. I'm not too sure. Oh, maybe like a CTF, was it? All right, cool. So CTF, but that's probably not part of a presentation. If they do, it should be a good presentation. What else am I missing? Oh yeah, and Ellie was doing a presentation on blockchain. Yeah, so he didn't know that, but now he does. So it's scheduled. By the way, do you want to show real quick clip since you're already there? Look for Peter the Cat on the internet.
Do we want to stream?
Yeah, you can stop the stream. So any questions, comments? Again, if you